So welcome, everybody. If you'd please make your way to the seats, we'll get started in just a minute. All right, thank you, and welcome everybody on this beautiful, clear day to this beautiful space. We're really so lucky. I'm going to start with thank yous because we're just so lucky to be here in this space, and I want to thank the Hariri Institute and the entire staff, especially Catherine D'Angelo, for hosting us, for making this space available to us, and for helping pull this together, along with Casey DeMarsico from the Center for Climate and Health and Emily Walton from the BU Urban Program. So thank you to everybody that makes these events possible. We're going to have on the agenda for today, we're going to start with some opening remarks and then move to a series of lightning talks. We're very lucky to be in a very rich ecosystem where research at the intersection of climate, biogeoscience, and health is not just possible, but really exciting. And so I think you're going to see that throughout the day today. Let me start by offering some remarks from Yannis Paschalidis, who's the director of Hariri, funded the focused research program that initially catalyzed a lot of this work, and is Distinguished Professor of Engineering. So Yannis.
Okay, good morning, and welcome to our great new building where the Hariri Institute is located. So climate change and health are typically viewed as very distinct and rather unrelated fields, yet we think that it is their interaction that is so critical in reducing the health effects of climate change, and also hopefully increase our society's motivation to take the necessary steps to decelerate climate change. So this was actually our motivation when we invested in the team that is led by Wellenius and Lucy Hutira to bring together the diverse talent we have at BU in this area. And the investment used the Hariri Institute's focused research program mechanism, which is a mechanism exactly designed to turbocharge cross-disciplinary interactions for impact, and also for helping these teams to achieve sustainable funding over a longer period of time. This FRP has actually been funded jointly with the Institute for Global Sustainability, another university-wide center we have at BU. The symposium today is a culmination of their efforts, and it's a great demonstration of the type of cross-disciplinary collaboration that engages faculty, staff, students from actually both of our Boston University campuses, the Charles River campus and the medical campus. And the symposium highlights research that has been catalyzed by BU Urban, which is an NSF training program led by Pam Templer, and also the Center for Climate and Health, which is led by Greg and funded by NIH. So I think there is an exciting program ahead of you for the rest of the day. Enjoy the day, and thank you for organizing this.
Thank you, Yannis, and again, thank you for making the space available to us today. Next, let me welcome Provost Gloria Waters.
So great to be here, and nice to see you all and see familiar faces here. I have to say, these kinds of events are the thing that make me glad that I'm doing this job. There are a lot of things that happen in the job as the provost, but when you see faculty and students come together around a wonderful event like this, this is why we're here. So thank you for inviting me to see what you're doing, because it helps brighten my day of all the things that are happening around the campus. So it's great to see these familiar faces, both from BU, and I know that there are even guests from the city of Boston, and what you have planned is a really amazing day of presentations, and hopefully people here will make new connections and those kinds of things. So I definitely want to thank Pam Templer, Greg Wellenius, and Yannis for the amazing work that they're doing, bringing together these different parts of the campus and really thinking creatively about how to bring together the work that's happening on climate and health. As Yannis said, it's not something that people typically thought about, I think, especially some years ago, but it's becoming an increasingly important topic to deal with. I think that, you know, one thing about this kind of event is that it really does embody exactly what we are trying to do here at Boston University. I think especially right now we are really focusing on the ways in which we can be differentiated and the ways in which we can bring together different groups of faculty working on really important issues from different perspectives in a very interdisciplinary way, and then come up with these you know, practical solutions. And I can't actually think of you know, many areas that our faculty are working on that are a better example of what's happening than the work that's happening across the 3 different centers that are really focusing, that are focusing and bringing this together today. So I think, you know, this idea of advancing cross-disciplinary and transformative solutions to the grand challenges that we have, that's exactly what you are all doing, and that's what we want to do here at BU. And I think it really is a recognition of what happens when you bring together these great researchers. And I think one of the things that's really impressive about all of the groups here is that everybody is committed to using their research and their work to improving the lives. And I think, you know, that is also, I think that there's something that the Hariri Institute has really focused on, is using computing and data science for social good and those sorts of things. So I think this really demonstrates the kind of power that we have at BU. One of the things that the centers have is the ability to convene people. And so it's really great to see when our various centers are convening people together. But I think the other thing that is really impressive is we have these interdisciplinary centers, and then when they connect, you really get interdisciplinary work happening. And this is just a great example of that happening here at BU. You know, I think I don't have to tell anybody, the topics that you're working on now are really important, and they're really important at this particular point in history. There are all these extreme weather events, there's steadily rising temperatures, we have aging infrastructure, we don't have very good public resources and those kinds of things, and so the ability to sustain our communities is really, really critical, and so it's really important that you're doing this work. I think, as I think Greg said, we are really lucky to live here in New England because this is a center of innovation, and I think both in the public and the private sector. And I think it's a place where people really do try to use the research to change people's lives and improve the way that we live. And I think it's really incumbent upon all of us, but especially academic institutions, to use the knowledge that we have to improve society and to make some headway in these huge global challenges, of which I'd say climate and health are really high up on the list, especially now as we are entering into this next stage of American history. So I know that you have a lot of really interesting things planned for today. I'm sure this is going to be very invigorating, and it's wonderful also to have so many students involved in this. This is something that is really special, I think, about the programs, especially the urban program. I mean, it's such a, I think we all at the leadership level talk about it as exactly the kind of thing that we want our faculty to be doing and that we want to expose our students to. So just want to thank you all for doing the work that you're doing. It's important and invigorating to me to see you all doing this. So thank you.
Great. Thank you so much, Provost Waters, especially for making the time. I know how busy you are, so really appreciate you taking the time to spend a bit of that with us today. As I said, there's a really rich ecosystem across the BU campuses. Today you're going to hear a lot about 2 of the units on campus that foster this type of work. One is the Center for Climate and Health, which is based out of the School of Public Health, and I have to thank Sandro Belea, Mike McLean, and the Dean's Office for as well as the chairs for supporting that with initial funding on an annual basis to really make a lot of what we do possible. And although this is based at the School of Public Health, this is really acting and serving as a cross campus center. And our goals, you can see here, are really to bring people together, to help people be even more successful together than they would be apart by using shared resources and by connecting with each other, and then to amplify the success of individuals and groups, both internal to the university and beyond. And the way we do that through a list of types of activities. We had, I think, last year about 15 events ranging from seminars to workshops to research gatherings to social gatherings. We have a really unique model of shared research staff, and what I mean by that is that we have 5 full-time research staff that are divided amongst several projects in a very flexible way, because when you first get a grant, it might be really hard to hire a whole FTE of a person, so maybe you need 20% of somebody with GIS expertise and 20% of somebody with statistical expertise and a program manager. And we have this very, what I think, at least in the School of Public Health, is a novel model of being able to share staff in a rotating way across projects that's really helped catalyze many of the initial projects into success. This model also brings people together in unusual ways. So we have, if you look at the products, the papers, the ideas, the meetings, the discussions, it's really highly collaborative, highly interdisciplinary in an unusual way. And it turns out that we have the good fortune that people seem to actually like each other. And so there's a lot of positive energy, there's a lot of trust, we have a lot of fun. We had a social event last night to celebrate ahead of today's event. So we just have a community that really enjoys spending time with each other for both research and fun. We've been particularly focused on the success of early career faculty, several of whom you will hear from today. And then we're in a competitive soft money environment, and so it's important to apply together with other units on campus for a number of funds, and to diversify away. We can't just rely on NIH funding or NSF funding. We have to have the alphabet soup that you see here that includes a variety of government agencies, city governments, non-governmental organizations, and foundations. And lastly, we've participated in the Emerging Scholars Programs both last year with the School of Social Work, this year with the Department of Environmental Health. And I think those types of interactions, again, help bring people together in creative ways and have been hugely successful. Let me just say that a lot of our time we spend doing research, but we also spend a lot of time enabling others to be even more successful and provide them the resources. This idea really started with the Hariri Focused Research Program that Yannis mentioned, that was funded jointly by Hariri and the Institute for Global Sustainability. And that brought together, that was co-led by me and Lucy Hutira, but brought together a number of faculty, staff, and students from across both campuses on a regular basis. And we had a number of very productive conversations and events and products from that. NIH has funded us for a 3-year, nearly $7 million grant to create the CAFE Climate and Health Research Coordinating Center. That serves the global community in climate and health, and that's we're about halfway through that right now. And that's, just look at the list of individuals and organizations that have participated in that. That's a joint BU-Harvard effort, but at BU it includes the Department of Biology. Pam Templer's been an active participant. Folks at IGS, Catherine Lusk, who I haven't seen yet, but I hope is here, from Initiative on Cities, and again, our rich partners at Harvard. We then grew that with additional funding from the National Science Foundation. Lucy and I and Dan Lee from Earth and Environment created GeoCafe to make sure we're bringing in the folks from the geosciences into this community, climate and health community. And then most recently, we have additional funding from the National Institute of Aging, which is part of the NIH, to create the Gateway Exposome Coordinating Center, which looks to, again, catalyze the global community of research on aging, part of which is through climate change or climate-relevant hazards in the built environment. So lots of infrastructure being built at BU to help not just ourselves be successful, but the broader, campus-wide and global communities be successful. And I'll end with this, just showing you that we have the CAFE conference is now an annual event. It is a large virtual conference. We had about 900 participants last year of our 3-day event. The second one is scheduled for March 3rd through the 6th. We're still accepting submissions for certain types of sessions. We're always looking for volunteers to help out. If you're a student, we're also looking to hire student employees. So please find Elaine Bertolini, who will be down shortly because she's on a call with the organizing committee of the conference. So with that, let me pause there and introduce my friend and colleague, Pam Templer, who's Distinguished Professor of Biology and the Chair of Biology. Pam.
Thank you, Greg, so much. It's nice to see all of you here this morning. I'm just going to share with you, similar to what Greg did, about the urban program. I know many of you know what it is. Thank you all for being here. But for some of you who it's new, I'm sharing with you because I want to invite you to join us. In case you don't know about us, we are a graduate program. Urban stands for the Boston University Graduate Program in Urban Biogeoscience and Environmental Health. We were a program that was established with a $3 million NSF research traineeship grant known as NRT. Why did we create this program? Well, we did it because we know cities around the world are facing many environmental challenges, whether it's related to climate, water, air, land use, in an increasingly urbanized world. We know that well more than half of the world's population lives in cities, and they're facing these challenges, and as Gloria said, we want to help people around the globe. We know to meet these challenges, we need to bring different disciplines together to tackle the problems, and that requires engagement with many different groups of people, whether it's cities, non-governmental organizations, or the private sector. Simultaneously, we know that students are really hungry for solution-oriented training that's interdisciplinary, and hence the urban program was born with the idea being that we're using cities as living laboratories for our training. So the mission of our program is to prepare our graduate students to tackle urban environmental challenges using an interdisciplinary approach centered on partnerships with governments, non-governmental organizations, and the private sector. I have this diagram up here. We use this because just in case biogeoscience is kind of jargony, but it's a discipline basically that's looking at how humans are impacting the environment. And we look at that as a perfect complement to environmental health, which is what a lot of what Greg was talking about and thinking about how those changes in the environment in turn impact human health. We're the only program that we're aware of where we've brought together these disciplines to look at the complementary effects of us impacting the planet and how those in turn impact human health. In our program, we look at how these all intersect mainly at the juncture of air, water, and climate, but we look at many other things in the environment as well. Our vision is to long-term create a diverse workforce of scientists and practitioners equipped with technical knowledge and communication skills necessary for building the sustainable, healthy, and equitable future we're all striving for. And with this, we really aim to have an inclusive and welcoming community where all members feel welcome, including all of you here today. So to that end, we have many in-person events like this one today. So thanks for being here, which we think is really critical for bringing people together, feel welcome, and collaborate and work together productively. And as Greg said, build trust and joy and fun in the work that we do. Just in case you don't know, the program leadership includes myself as director, Lucy Hutira and John Levy as associate directors, and Emily Walton as our program manager. As Greg said, with the public health side of things, we also are across campus. So again, welcome to all of you who are here today from biology, computing and data sciences, earth and environment, environmental health, and math and statistics. We have folks from the Institute of Global Sustainability, Climate and Health, Initiative on Cities, and the BU Biogeoscience program. Many of you are involved in urban, so again, so great to see you. Lots of faculty and staff, and if you're not on this slide, we welcome you reaching out and getting yourself added because we'd love to work with you. And of course, the students are the center of our program. These are pictures of the 5 cohorts that have completed their first year in the program. And this slide here shows you our current cohort. And I bring this up because I just want to show you the diverse backgrounds that our students have, whether they're in biology, earth and environment, environmental health. Some years we have math and statistics, as well as computing and data sciences. And so just to give you a little bit more details about what the students actually do, what you guys do, is they take courses in biogeoscience, environmental health, statistics, data analysis. We run workshops in professional development, urban governance, science communication, and the whole goal here is to prepare our students so that when they graduate, they can pursue whatever work they want to do. And a big focus of that is the internship. So we do lots of training and courses and workshops, and ultimately we want to prepare them for internships where they work with their choice, government, non-governmental organizations, or the private sector to use their technical skills, scientific communication skills to tackle an urban environmental challenge. So these are just some examples of many hosts that our students partner with. I thank Emily and the program managers before her, Heather and Evan, who basically really work hard to meet the needs and desires of our students to work productively with the hosts that they partner with. And so for the rest of the morning, what we're going to hear from is a whole series of talks about, just to give you examples of the many partnerships our faculty, students, staff, and alumni have all participated in. I'm really proud of the community we have. It's not me, it's all of us working together collaboratively within BU, but also with the partners that we bring together, including many of you who are here today. So I'm going to kick off with Lucy, and the topic here for all of our lightning talks is actionable research in climate, biogeoscience, and health across Boston University. That's going to be followed by a panel discussion led by Lucy. Just a reminder for all the faculty, you guys get 4 minutes. Emily, who's sitting right in front of the podium, or Casey, one of you is going to hold up a sign saying you have 1 minute left. Casey's going to ring a bell that when your time is up, we're going to ask you to please exit the stage just so we can keep this moving and make sure we have time for everybody's talks. So I'm going to call up Lucy. I'm not going to introduce each speaker, so please be ready to come up as soon as the last speaker is done. All right, Lucy, take it away. Thank you.
So I'm going to go back in time a little bit today in my lightning talk and think about the long game in thinking about how we solve problems. So the title of my talk is Measuring, Monitoring, and Modeling Urban Greenhouse Gases. So back in 2017, Catherine, who I just saw slip in, helped us write a grant that was called CO2 USA. This was a kind of crazy, like $1.5 million grant from NOAA that NIST also collaborated with. And what we did is we had 6 US cities that had developed an infrastructure around monitoring and modeling greenhouse gases in cities, trying to think about, are cities actually reaching these pledges that they're putting out there? And thinking about what's the data that they're using, what's the role of the biosphere, how do they actually model the movement of air? In addition to measuring CO2 in the air, it moves. And a big piece of what we did in this was we held a series of workshops and stakeholder engagement events trying to think about where are the information gaps in what do people know that they know that they don't know, and where is the scientific community and the policy community completely misaligned in realizing what's possible and what's not possible. CO2 USA, which focused on CO2, led to CO2AQ, which Jeff Geddes then joined this team, and we started looking not just at CO2, but at air quality and different pollutants and kind of the co-emissions profile of what happens when we start to track this and we try to model reductions in one and what it means for the other. So we held a series of workshops, and I've put up here the agenda for one of them that goes back to 2019. And this one was at BU, although the picture on the right is from the second workshop that we held at the University of Utah, which Catherine has a giant smile on her face. I have never led a breakout group in a football stadium. It was kind of cool. But what we did at these workshops is we brought together the academics, the scientists that were actually doing these measurements, and Google, the Carbon Disclosure Program, I think, ICLEI. We had the mayor of Salt Lake City. We had city officials, and we worked on trying to figure out these questions of what we know and what we don't know. Here's a nicer picture of the BU ballroom from another one of these meetings. So why have I gone back to a program agenda from 2019? Well, it took a while, but what we did is now built the foundation for the U.S. Greenhouse Gas Center. This launched about a year ago. Over the last few days, they've been doing stakeholder engagement where our program for CO2 USA focused on cities. The U.S. Greenhouse Gas Center is doing everything, cities and beyond, energy production, and it's really cool to think back on having had a small piece of shaping what this entire center looks like. And at this point, you might be like, that's awesome, Lucy. There's an administration change coming. This may not survive. I think it actually might, because the participants in this week's stakeholder engagement were the energy companies in the private sector. it's moved in what it looks like. There's been that tracer of CO2 and air quality. We led the way in the greenhouse gas and air pollutants emission system, which has been released for the United States. Week after next, I go back to Washington for my 3rd trip in 1 month to lead a panel like the one I'm going to do in a few minutes about how city data can be used to inform these sorts of questions around greenhouse gases. So sometimes it takes a while. Sometimes there's hiccups along the way. But I just want to give a story about how the long game can pay off in the space of greenhouse gases and CO2. And I'll acknowledge my partners. There were many. We were one of the institutions, but Harvard and University of Utah were really important in this. And Catherine, who probably didn't know how the story ended. Kevin.
Thanks a lot, and thank you for inviting me to be able to help share and talk a little bit about a story on how BU can be a centralizer and catalyze in research globally to help support climate health research. And I'm going to use the example from the Climate Health and Air Pollution Research Study we refer to as the CHAIR India-based study. And really, this project was fundamental. I remember a year into this project, we almost were still not yet even starting our mission, and it had a lot to do with difficulty with getting technical services where researchers from all these institutions that you can see below trying to collaborate with one another in big data sort of processing, which is doing a lot of geospatial raster conversions, so we could develop nationwide 1 by 1 kilometer daily measures of PM 2.5 and temperature that sometimes we think we take advantage of here in the United States. We have those exist, and there's global-based models as well, but collaborating with local India researchers, having the same access to those mortality studies to help inform policies was not readily available. There was monthly and yearly based models, but there was this missing piece. And I can really tell you, like, if it wasn't for the help from BU RCS and transitioning to the BU's cluster-based system to be able to support 16 different researchers from 3 different countries and 6 different institutions. So with the help of people like Dennis, Gerard, Charles, Wayne, like all from RCS, this really wouldn't have happened as well. But our goal was really to provide that technical support to researchers in India to be able to develop these models using robust machine learning applications. So it's nice to be able to see that the climate health work that we're doing also integrating in with machine learning and data science, since we're in this building together. And that's really a central theme of this work is we were trying to collaborate and provide an opportunity to build these models using these machine learning approaches that you can see on the left, so we could have really nice exposure models that you see on the left side, sorry, my right, your left, and being able to do these sort of health studies that are pivotal to help inform policy development or inform new standards. And I just came back from a meeting 2 weeks ago in Stockholm where we were just wrapping up this 4-year study, and we're making all this data publicly available as well through some efforts that are aligned with the institution as well, through CAFE and the Harvard Dataverse. And the goal here is not just to like build these models, but to help push research forward. So there's researchers globally that have already started to analyze the mortality impacts at a daily level, and also to develop hotspot space-time cube-based model and approaches to understand where and what could be the triggers in India in relation to these elevated peak exposures to PM 2.5 as well. And a key resource that we're not only providing on some technical side and on our side of the project that's being led by myself, but also Greg Wellenius, Amrita Nori Sama, who's now at Harvard, and then also the great work by Muskan as well. I'm not sure if Muskan's here. Oh, there you are. Hey, what's up, Muskan? Perfect timing. But really, to help make this information accessible. There's a number of groups, especially IGS and other areas, that are trying to integrate in data for dashboard development so it can be not just for researchers, but also for policymakers, local communities to be able to work with these sort of data sets. And there's the link to the tool that Muskan built for us as well. And I just want to quickly acknowledge that this project was funded by the Swedish Formats Group, but also a number of other researchers that I can't fully list the name because it's so large, but our directors are Peter Lunchman as well as Purnima Parakan at Ashoka University as well. So thank you very much.
All All right, good morning, everyone. So I want to tell you a brief story about the ACRES project. This is an ongoing research project we have in the Department of Environmental Health, and it is based in the Mystic River watershed of Massachusetts. This is 21 communities, cities, and towns in eastern Massachusetts. It includes a bit of Boston, Charlestown and East Boston, as well as some nearby communities like Chelsea, Everett, and Revere, and then stretching out to the suburbs. And these are communities that have been very concerned about climate change for some time and making efforts to try to address climate resilience. So they're trying to get themselves ready for extreme weather events, flooding, extreme heat, and so forth. And these are also communities that have a lot of chemical exposures in their midst. There's certainly air pollution from traffic, from airports, from other sources, and there are a lot of chemical facilities in and around those waterways. And so this project is an attempt to work in partnership, folks at BU and folks with the Mystic River Watershed Association, to try to understand the cumulative effects of climate stressors and chemical stressors, and in particular, how it is that some of these climate stressors could make the effects of chemicals worse. And so what I'm showing here is a map, obviously, that shows the Mystic River watershed area that's outlined in black. And there's a number of geospatial layers here developed by some of the excellent team members, including Muskan, previously referenced, Zach Pop, and others on our team. And so you can see here that sort of, kind of reddish color, that is a temperature layer, where you have higher temperatures in the urban core, where you've got less green space, more pavement, more impervious surface. There's also little dots there that might be hard to see that show various kinds of toxic release facilities, Superfund sites, other facilities where there are chemicals in that space. And we also have a flooding map up there that shows, I think, there's a current flooding and projected future flooding. And so part of the goal here is just to understand the overlay and intersection across these stressors, and then to, of course, think about what the combined health risks might be. As I mentioned, we're doing this in partnership with a community organization. We're trying to be responsive to their needs. There's a lot of fun scientific stuff we can do to understand cumulative exposures and risks, and we'd like to build our toys, but at the end of the day, we want this to help the communities in this region. And so the research questions were designed and motivated by them. The outputs are ultimately meant to be tailored to their interests and needs, and we're doing a lot of other activities in the community to make sure that the work that we're doing is getting into people's hands. So I guess from left to right, we were at an event at the Museum of Science in Boston, just trying to communicate a little bit about some of what we were doing and the importance of climate stressors like heat. We ran a data dashboard workshop, principally for people who worked in municipalities and city government, who needed to potentially learn a little bit more about our methods, and then doing other things, again, to convey information to community members, and ultimately doing some things like participatory mapping to get their insights about what they see in their communities relative to what we're seeing. So with 1 minute to go, I won't get into the fun toys that we're doing, but again, methodologically, we're interested in looking at the combined effects of multiple stressors, cumulative exposures. We're doing some novel statistical approaches to build synthetic populations so that we can better understand environmental justice patterns in the community. And again, using our strong community partnerships to make sure that we are responsive to their needs, including designing new analyses that weren't originally in the grant to be responsive to input that we're getting from folks like the Massachusetts Office of Technical Assistance, who are very interested in the confluence of flooding and chemical stressors from facilities to make those facilities a bit more resilient to climate change. So just want to acknowledge our fantastic team, faculty, staff, and students at BU, and our partners at MIRA, as well as funding from the US EPA. Thank you.
Good morning. My name is Danny, and I'm an associate professor in the Department of Earth and Environment and Mechanical Engineering. I'm also one of the Urban Age associate directors at Initiative on Cities. As you can see, my title is called Urban Climate Modeling from Global Change to Local Actions. Climate modeling is nothing but solving a bunch of nonlinear partial differential equations on grid cells that we use to discretize the Earth. So you can see that it's already getting pretty technical, but actually it's quite simple. You can see that we use the grid box to discretize the Earth. And this grid box tends to be very large. They range on order of 50 to 100 kilometers, since the Earth is vast. So the questions that we're interested in are happening in cities that are actually quite small. So we cannot really resolve cities in this type of modeling. But it's important to have cities in those type of modeling, because humans are moving into cities, so we care about the climate conditions in cities. And also, the cities are creating their unique climate, things like urban heat islands, that exacerbate the heat risks, caused by the climate change. So one big theme in the research that we do in my group is to represent cities in this type of models, use sort of conceptual models like this that you see on the right, where we are trying to not resolve every single different city in different ways, but to represent kind of the gist of the cities in terms of the physical processes. And once we couple this type of model into the global climate modeling framework, this will allow us to look at things that the interaction between urbanization, global climate change, and in particular, we will also look at how building energy consumption, at least in this type of modeling, is affected by climate change. So this is partly because the project was largely funded by Department of Energy, so they're quite interested in how climate change and urbanization would actually interact with building energy consumption. And as we use more, for example, air conditioning in the summer to combat heat stress risks, we will actually generate more anthropogenic heat flux or exacerbate actually the outdoor heat level. But this type of modeling is cool. However, a lot of the climate actions are happening really at small scales, that this type of physical modeling or physically based modeling are not really very useful for this type of questions. So the way that we approach these local actions is to use this approach called dynamic downscaling. So we go from essentially the global view, which gives us the global vision, down to things that we're really interested in, with whether it's a regional domain or even a local domain. As you can see in the bottom one, we are looking at essentially a small domain that is actually in the city of Boston. So an example is that we collaborate with Patricia's team to look at this project called Sea Heat. So there are community-driven heat mitigation plans that are really happening at local scale. So this is called the cool block. So you can see that they really want to just plant a few trees along one street and then turn one of the parks, one of the pavement into parks. So we use this type of really hyper-resolution simulations to look at the effects of these heat mitigation strategies, whether it's having the grass park or having street trees or having a combination of these. So hopefully this gives you a flavor of what we do, going from global scales down to the local scales. And I also want to highlight some of the funding support and also highlight the fact that we are using a lot of computing resources from Hariri. And that's all.
Hi everyone, my name is Marcia Pescador Jimenez and I'm an assistant professor in the Department of Epidemiology. So my research focuses on how the neighborhoods where we live affect our health and well-being. And for the past few years, we focused mostly on green space and the beneficial associations with cognitive health. So this is an example of a recent publication in EHP where we showed that greenness at midlife was associated with a slower cognitive decline later in life. What we saw was that higher exposure to greenness was associated with a 0.004 slower cognitive decline. And just to help interpret this estimate, when we regressed age on cognition, we saw that age had an effect of negative 0.006. So just all these numbers to say that increasing greenness seems equivalent to a slowing cognitive decline for about 8 months. We also compared participants in the highest exposure group to the lowest exposure group of greenness, and where we saw that overall everyone experienced cognitive decline, participants with higher exposure to greenness experienced a slower cognitive decline. However, most of this research has focused or has used satellite-derived metrics of greenness. And so in more recent analyses, we're using Google Street Views and deep learning algorithms to get at the specificity that we need for policy interventions. So we have downloaded 300 million Google Street View images, and we run deep learning algorithms to get at the percentages of, say, trees, grass, flowers, et cetera, around the US. And we're using these metrics in racially diverse cohorts to study associations with health outcomes. So Dr. Tara Jensen, a postdoc in my lab, is using Google Street View data to examine environmental injustice. And what she's doing is she's using multi-level analysis to cluster participants according to race, ethnicity, education level, and neighborhood socioeconomic status to see if these clusters predict access to green space. And what she's finding is that the trends that we would normally expect for higher education, higher neighborhood socioeconomic status with higher exposure to percentage of trees, they hold for non-white participants. But the reverse trends are observed for white participants. So all this to show is that it's important to look at the combination of social factors in association with access to greenness. And speak of combination, we also know that environmental exposures are not experienced in isolation. So our lab is using an exposomic approach to look at green space in combination with temperature, noise, walkability, air pollution, violence, and we're doing these in multi-cohorts across the United States to study associations between the external exposome and racial and ethnic disparities. On this, Cameron Reimer, another lab member, is looking at associations between the external exposome in association with MRI biomarkers of dementia, and what he is finding is that the exposome index is associated with white matter fractional anisotropy, which is the higher the worst. And what we are finding, as you can see on this graph, is that metrics such as PM2.5 rank higher in the exposome index. So with that, I just want to thank my mentors who are included in the slide, and also NIH funding. Thank you.
Hi, good morning, everyone. My name is Ian Sewing. I'm a professor in the Department of Earth and Environment. I'm an economist, and I study climate change impacts. The work that I'll talk to you about is social vulnerability in a warming climate. This is a simple exposure study where we use a lot of data from climate models, about 15 terabytes worth, to understand where vulnerable communities in the present climate might face risks in the future climate because of warming, okay? And so climate change is going to shift the distribution of temperatures differentially, so different places, different regions. And especially in communities with vulnerable populations, we want to understand is the tail of the distribution, it's going to shift. So how many more days are you going to exceed the current extreme, the current 95th percentile? How many additional days of accumulated heat will we have? We saw in Phoenix, Arizona, more than 40 consecutive days of 100+ temperatures. And then how many days out of the year will those maximum temperatures reach critical thresholds beyond which we think is really, really dangerous for health? For instance, a maximum temperature that's been quoted in the literature about 37.5 degrees Celsius. And the other part of it is, as the nation grows and demographics change, do we think that these vulnerable areas are going to gain in population, so we'll see more and more people exposed to these different kinds of extremes? And we address this by overlapping information on demographic projections, climate model output, and current climate, current period indicators of the social vulnerability index. If you look at these maps on the left-hand side, what you're going to see is exposure in the present day. And on the right-hand side, you see the change in exposure we would expect out to mid-century, given by the average of 2041 to 2060. If you start at the bottom, acute heat exposure, what we see is the maps show the overlap between the social vulnerability index at the census tract level and first of all, where the 95th percentile temperatures are and how those are going to change in the future. And what you see is kind of the map is smooshed all over the place. That just tells us that in the future, the tail is going to move all over. Every place is going to have more tail risk. Every place is going to have the 95th percentile shift outward by different amounts, but it's not spatially differentiated. If we look at the top row, that tells a different story because that's where chronic heat is going to occur. Cooling degree days, the measure of accumulated heat above 18 degrees Celsius, in this case over 24 degrees Celsius for AC over the course of the year. And in the middle, the extreme heat, which is this above 37.5 degrees Celsius, and we see a lot of that up in the eastern part of the mountain region. Finally, what we can do with this for action is we can drill down to where you have greater than the top quintile of SVI and understand the census tracts that are most exposed to the top quintile of heat of different types and SVI of different types, and look at the blue. A lot of them are going to be represented in Texas, and particularly in Houston, which is the largest metro area, and the site where you have a lot of social vulnerability in different census tracts. And I'll stop to let the next person go, and this was funded by our DOE grant as well as Hariri. Thank you.
Like 90% sure I'm next, but there it is. Cool. Hi, everyone. I'm Mary Willis. I'm an assistant professor in the Department of Epidemiology over on the other campus. And today I'm going to talk to you about a pretty large-scale accountability study of traffic-related air pollution regulations and population health. So we asked the question, to what extent has the billions of dollars spent on improving tailpipe emissions actually yielded positive co-benefits for population health? So traffic-related air pollution is a pretty complex mixture. There's a few of the key pollutants in tailpipe emissions are listed above. And what's considered generally to be a good marker of this mixture is nitrogen dioxide. And since 1995, we as the US have focused on reducing nitrogen dioxide, and we've had some pretty solid successes, right? We've reduced it by about 50%. That's the red line in that figure. At the same time, we've maintained roughly the same number of vehicle miles traveled on the roads. The number of miles a given car is running on the road is roughly the same over time, at least in our study area. And so we embarked on the Transit Accountability Study in Texas. Our first aim was to examine the impact of vehicle emissions regulations on traffic-related air pollution exposures and associated changes in adverse birth outcomes. Adverse birth outcomes are really highly linked to nitrogen dioxide exposure, so we figured if anything is going to see this improvement, birth outcomes is probably a good one to focus on. And then we also asked, how do local congestion reduction programs change the impact of traffic-related air pollution on adverse birth outcomes? All of this was only possible because, one, of all things, Texas has really good open records laws, really surprising to us. And two, Texas A&M has a transportation institute of people who work full-time on traffic data year in, year out. There's about 900 employees, and we cold emailed one of them, and turned out he'd been measuring traffic congestion in Texas every single year since 1983. So he has helped us out a lot here. And so what we found really briefly, aim one, traffic regulations over time. This is the association between vehicle miles traveled and adverse birth outcomes by year. And while we do see this really nice kind of reduction there, it's not nearly the magnitude you'd expect of a 50% reduction in nitrogen dioxide. So we got to that point, we're like, okay, maybe we've focused on the wrong thing. Maybe nitrogen dioxide isn't necessarily the best marker of this mixture. Let's go on to these congestion reduction programs. This is totally gonna be the right thing to look at. And again, probably not. We looked at electronic tolling, so taking out an overhead toll in favor of a non-stop and go system. We saw maybe a little bit of an association of taking out toll booths, but we looked at all sorts of different types of tolling based on recommendations from the traffic engineers, and we didn't really see much. Then we also looked at construction projects, such as adding a lane to a highway, adding different sorts of traffic light systems, and we saw basically nothing. So we got to the end of this project, we published our papers, and we're like, either we're just wildly wrong about how all of this works, or maybe these smaller scale roadway projects aren't the way to look at this. And so we started talking to a lot of different community groups around the US, specifically focusing on Austin, Texas, where we happen to have been working, in New Orleans. And they asked us about what about these bigger scale changes to the transportation landscape, such as highway reclamation, thinking about things like the Big Dig. We haven't started on this part yet, but it seems like maybe some of these really big scale things are where we should be looking in the future. I'd like to acknowledge our team across 5 institutions now, and it was funded by the Health Effects Institute. And I'll pass it on to the next speaker.
Hi, good morning. I'm Nina Brooks. I'm in Global Health on the other campus. And I'm excited to share a little bit of my work on the traditional informal brick manufacturing industry in Bangladesh. So informal brick manufacturing is a major source of greenhouse gas emissions and air pollution in South Asia and in Bangladesh. And in the region, it's a particularly high concentration of air pollution globally. And so solutions that can reduce the greenhouse gas emissions and air pollution have the benefit of achieving health co-benefits while also reducing the climate impact. And so we developed an intervention with engineering partners that reduces the improves the energy efficiency of brick manufacturing, while at the same time increasing profitability for kiln owners. And so in weak regulatory states, this approach is particularly promising because it aligns with the profit motives of kiln owners. So this work required the engagement of a lot of key partners. So first is the Bangladesh Brick Manufacturing Owners Association. It's essentially a trade association that represents the interests of traditional brick manufacturers. And so their collaboration and partnership with us was really central to getting kiln owners on board with changing their manufacturing practices in the study that we conducted. And this relationship was developed through a really long-term engagement with the International Center for Diarrheal Disease and Research of Bangladesh, or ICDDRB, which was our main research implementation partner for this work. And so they have been, and we've been working with the brick industry for almost a decade, and so really cultivating these relationships to get them on board with changing manufacturing practices to be more energy efficient. We also partnered with the Bangladesh University of Engineering and Technology, which is a top engineering university in the country, to help implement this intervention. And their participation, along with that of ICDDRB, really lended a lot of credibility to us when we were meeting with the government and presenting our findings, since they're really well-respected institutions in the country. And then last on this slide is Green Technology Solutions, which is an energy consultancy based in India. And they were really the masterminds behind the efficiency improvements that we developed for this intervention. They have many decades of experience working with kiln owners and really understand the perspectives and incentives of brick manufacturers, but also have very deep, extensive engineering expertise to understand how to improve the manufacturing processes. So just to highlight a few results from a recent randomized controlled trial that we conducted in one division in Bangladesh. We had really high adoption. Over 65% of our intervention kilns adopted the improved practices, which changed the process of firing with coal, and also changed the practice of stacking the bricks inside of the kiln. So we saw around 65% of kilns adopted these improved practices. And as a result, we saw really substantial reductions in energy consumption and in carbon dioxide emissions. We also saw that kilns that adopted these practices were using or spending less money on coal per brick produced, which is their most expensive input, and also produced more of the highest quality bricks. So this sort of confirms the profit motive for this intervention. We did a back of the envelope calculation to value the CO2 reductions using the social cost of carbon, and found that the benefits of this outweighed the costs, which were primarily the training of our staff and also of the kiln owners, by a factor of 65 to 1. So a really cost-effective way of achieving both climate and health benefits. So we presented our findings to the government in 2023, and as a result, they requested that we expand this work in Dhaka division, which is where the capital of Bangladesh is based, and by far the most polluted area in the country. And so last year, during the brick firing season, we expanded our work in Khulna and also in Dhaka. This year, we're continuing to work in all of these regions, reaching a saturation of around over 1,000 kilns, which is quite a few kilns of the total in the country. And we've also now started to identify partners in India to bring this work there, because bricks are manufactured similarly. So lastly, I already mentioned a few of the key collaborators for this work, but just wanted to acknowledge other implementation partners and collaborators at Stanford University, and also the Department of Environment and Ministry of Environment, Forest, and Climate Change in Bangladesh, and of course our funders from Stanford Impact Labs, Open Philanthropy, and the J. King Climate Action Initiative. So thank you very much.
Thank you so much. Those were a great set of talks. So now I'm going to hand it over to our next set of talks. We're going to have a combination of students, staff, and alumni giving our talks. In this round, we have 3 minutes each, so just keep an eye on Emily, who's going to give you an indication when you have a minute, and then the bell will ring from Casey when your time is up. So come on up, Quinn.
All right, thank you. Hi, my name is Quinn. I am a doctoral candidate in the Department of Environmental Health. I am also an urban trainee. Today I'll be sharing some of our ongoing work that highlights how cross-disciplinary collaborations can shape early warning systems for vector-borne diseases, which are increasingly sensitive to our changing climate. Oops, sorry, there we go. So climate change is already reshaping the global distribution of infectious diseases, and vector-borne diseases specifically, which are transmitted by things like mosquitoes and ticks, for example, are particularly sensitive to environmental changes. However, it's not just about climate. Disease transmission is influenced by a really complex web of factors, things like socio-demographic characteristics, environmental conditions, and climate-related changes all work together to create hotspots for disease outbreaks. So understanding this complexity is really critical to improving disease prevention and control efforts. So building an effective early warning system means accounting for all of these many interconnected factors that drive disease risk. This requires methods that are capable of accounting for the complex and often nonlinear relationships that occur between risk factors. And for example, integrating diverse data sets, like I've shown up here, things like satellite imagery for environmental and climate trends. We have sociodemographic survey data, disease surveillance data, and then information about the local urban environment. These can all provide a fuller picture of disease incidence. And with these data, we can then use a number of different methods, including things like machine learning, statistical methods, mathematical modeling, to create forecasts several months in advance, which can enable hospitals and governments to prepare ahead of time. Specifically, these forecasts can be used to guide early disease detection. They can be used to promote interventions like insecticide spraying or community-based prevention campaigns, all of which are making responses more cost-effective and impactful. So our team is working on applying these ideas to build an early warning system for visceral leishmaniasis in Brazil, which is a parasitic vector-borne disease that has an incredibly high case fatality rate. And existing control programs are largely reactive, and they have not been successful yet in reducing transmission. So by anticipating high-risk areas and high-risk time periods, we can enable early interventions and help to reduce disease spread. So to achieve this, we're comparing different modeling approaches to understand which models are most effective. And we are also using solely publicly available data to make this more accessible and implementable at a local scale for governments to do in their future forecasting efforts. And I just want to highlight that this work really exemplifies how multidisciplinary approaches, blending things like climate science, epidemiology, public health, and policy, can fundamentally change how we respond and react to disease outbreaks. And I just want to acknowledge my wonderful team, some of whom are listed here, but many are not. So thank you all so much.
Hello everyone, my name is Emerson Conrad Rooney. My pronouns are they, them, and I'm a PhD candidate in biology and a trainee in the urban program. And today I'll be discussing nature in national climate assessments, my urban internship with the US Global Change Research Program. My project with the US GCRP stemmed from the fact that there has been increasing federal focus on nature and nature-based solutions, including the call for the first US national nature assessment. However, the term nature itself is broad, and there is no standard definition for nature in federal reports. So the US GCRP wanted to know how nature topics were currently being covered in national climate assessments, which they release every 4 years and are a premier authoritative report on the state of the science of climate change in the US. So for my internship, I investigated nature-related themes and vocabulary in the 1st through 5th National Climate Assessment, and then developed recommendations for improving the consistency in nature-related content, both in current and future national climate assessments, but also to help with the development of the 1st National Nature Assessment. I found that the discussion of nature in national climate assessments has shifted over time. This figure shows nature-related theme coverage percentage on the y-axis with an NCA on the x-axis from past to present. And I found that early NCAs focused more on the impact of climate change on ecosystems, while later NCAs have highlighted more the solutions that nature can provide, as well as implications for environmental justice and equity. Through my urban internship, I had the opportunity to present my findings and recommendations to a range of audiences. So I began my internship in November 2022, and then in the following March, I presented to the National Nature Assessment Federal Steering Committee, and then at the 5th National Climate Assessment all-author meeting, where they were in the process of revising a draft of the 5th National Climate Assessment. I then presented my findings to the scientific community more broadly at the American Geophysical Union meeting, and then was invited to write a paper for a special issue on national climate assessments in the journal Climatic Change. I presented another poster to the Ecological Society of America community, and then most recently have been invited to be an author on the 1st National Nature Assessment chapter on assessments and frameworks in the nature assessment space. And I look forward to continuing to study how we can better promote and protect nature, including in the federal assessment space. And I would just like to thank everyone who made this internship project possible, especially the BU Urban program.
Too excited to get started. I'm sorry for almost cutting you off. Okay, hello everyone. My name is Emma Gauze. I'm a research scientist at the Center for Climate and Health, and today I'm going to be talking about heat vulnerability and sort of going beyond the average effects. So we all know that heat is bad for our health. There's pretty conclusive evidence, thanks to many of the people in this room, in fact, that, yeah, heat is bad. But the next questions that we should be asking are for whom, when, and where. So these are the questions that really will be able to allow us to target potential interventions to try and, leverage to see if we can sort of mitigate, hopefully not exacerbate. So how do we actually identify those who are most at risk, right? Our typical analysis methods, like regression techniques, are good at getting an average effect. So for the population, whatever the average effect is across the board. But what we're interested in here is really for whom and where, so subgroups, not the average, but for what pockets of the population is heat even more bad for your health. So traditionally, we can do that in 3 ways. One is hypothesis testing. So we say, we think this group is more vulnerable, let's subset or do an interaction term. So for example, this recent publication looking at mortality among those experiencing homelessness. And that's great, but you have to know ahead of time what you think, have that hypothesis. Next, we can decompose variance and look at the conditional results. So you can see this figure here. You have the population average effect, that purple line on your right. But then within that, you have subgroups that are a series of different effects. So looking at decomposing variance to look at those strata-specific estimates. And that's work that we're conducting right now with some IOC funds. And then finally, you can focus on small geographies, so the where. And this is work that started with focused research project funds from Hariri and that we're continuing now, and some initial results there. But there are some caveats. The other title of this talk should be blocked at every turn. So why aren't more people doing this? Because it's really, really hard. First, we have small numbers problems. If we're looking at small geographies, there's sparsity. There's identification issues. It's hard to get the health effects. 2, the complexity of statistical models. So decomposing variance, not the easiest thing to do. Spatial statistics, also not the most easiest thing to do. And finally, computation time. So just to give you an example, one of the models we're running now, when I first fit it, we're having convergence issues, right? So we're going with an MC-MC approach so that it's a little bit more flexible. We've tailored it, we've tinkered with it, but the run time for that model is approximately 15 hours. So if you miss something or you want to tweak something, that's another 15 hours. So this is just a little bit of a teaser, preview of some of the things that we're doing at the center, looking at this decomposing variance, getting at population subgroup specific estimates. So please come and talk to me if either you have tips, I would love to hear them, or if you want to chat about the potential for doing sort of this direction of research. And I have done this research certainly with an amazing team, some of whom are listed here, but I've talked to everyone I know about it, so thank you all.
Alrighty, hi everybody. My name's Alex Geiser. I'm a PhD candidate in the biology department, and I'm excited to share a bit of my dissertation work with you today. So climate change is altering host, pathogen, and environment relationships and causing the expansion of pathogens into new geographic ranges. In particular, these two species of pathogenic Vibrio are expanding and increasing rapidly. Vibrio vulnificus is responsible for necrotizing fasciitis wound infections, and Vibrio perihemolyticus can cause usually self-limiting gastroenteritis, all due to either wound exposure or consumption of seafood. So this map shows the average of 80 cases per year rising. It was rare to even have a case in New England, but now it's super common. Climate change is also increasing the strength and frequency of extreme weather events, which creates a lot of exposure. You probably see these headlines from this past summer and all those hurricanes in Florida. So these two species are prolific at forming biofilms, and they can be found on anything from rocks to crab carapaces, but not all bacteria substrates are created equal, and it's thought that there might be this reservoir for pathogenic Vibrio that has gone largely overlooked in most coastal systems, macroalgae. So macroalgae could act as this nutrient-rich protective substrate for the bacteria to proliferate. And there was one study done previously that looked at one species of macroalgae. So we thought, hey, why don't we look at a bunch of species? So we found that macroalgae indeed is a habitat for both Vibrio species. We looked at 7 different genera of macroalgae, and out of all the samples we took, 50% of those samples grew Vibrio on a selective agar. 100% of them, of those ones that grew, had perihemolyticus, and then 43% also had V. vulnificus. And 87% of the pathogenic, of the perihemolyticus was pathogenic. Don't be afraid of seaweed, but also don't jump in a pile of seaweed with an open wound, maybe, is the takeaway here. Thank you all for listening. Find me later if you have questions. I could talk about this for an hour.
Okay. Hi, everybody. My name is Jonathan Lee. I'm a student, PhD student in environmental health, also an urban trainee. And today I'll be giving a brief talk on the interdisciplinary methods that we used to evaluate green infrastructure at the local scale and their effects on ambient temperature and on extreme heat, which on a day like today feels really distant, but during the summertime we know is getting worse. And so as Dr. Dan Lee alluded to in his presentation, the Cool Block was born out of the Sea Heat Study, which is the Chelsea and East Boston Heat Study, a community-engaged participatory research project based in the BU School of Public Health that really attempts to, one, characterize extreme heat and ambient temperature in the communities of Chelsea and East Boston, which are environmental justice communities, and two, identify ways that we can spur local action. And so the Cool Block was born out of a mix of municipal and philanthropic funds to essentially combine all of these different green infrastructure projects to this one particular block. So you can see on the bottom the timeline of the events that took place, which include things like tree planting along a street, resurfacing of the road to lighter pavement material, and finally, a conversion of a vacant lot into a green space, which you can see in the picture listed there. And the CHE project has a lot of different activities as well, and so if you're more interested, definitely check out our website. And so one of the approaches that we took was through the CHE project, we have really fine scale, neighborhood level ambient temperature data that goes from 2020 to 2024 along multiple different sites. And so what we did was compare the cool block site to 2 other control sites longitudinally. And so the graph here shows the differences between the cool block site and those 2 controls over the years, pre and post the intervention. One of the sites has a very similar land use type to the cool block site, which is shown in the red line. So you can see actually that post-intervention, the temperature actually did decrease compared to the other site that has a similar land use type. And with Admiral's Hill, which is a very green space, higher elevation, there hasn't been much change there compared to that site. And we also collaborated with several different researchers in Earth and Environment. So Dr. Lucy Hutira and Dr. Ian Smith did some analyses looking at satellite imagery and their impact on albedo and land surface temperature around these sites, and also with Dr. Dan Lee and Hang on running simulations to see if we can capture some of that signals there, and we do see some promising effects. Just wanted to acknowledge a brief short list of some of our collaborators, without whom this would not be possible. Thank you.
Hello, everyone. I'm Ian, and today I'm going to talk about how we can make decisions about allocating climate solutions, including tree canopy and cool roof or white roof expansion in order to reduce heat exposure in the city of Boston. And the first question that we ask is how do these climate solutions actually decrease the air temperature? We know conceptually that tree canopy expansion and cool roofs should decrease the air temperature, but the actual magnitude of this reduction is less constrained. So we do this through leveraging a weather station network, which you can see on the left-hand side for you, across southern New England, where we have weather stations concentrated across 5 urban cores, where for each one of these weather stations, we have information on the land cover composition that you can see in the zoomed-in image here, including 100 meters around each weather station. And we also know what the reflectivity within 100 meters of the weather station looks like. So we can derive relationships like you see here to quantify how increasing tree canopy cover and increasing reflectivity through cool roofs can reduce the air temperature. And so this would be great if we could just sort of wave a magic wand in order to increase tree canopy or convert all our roofs to cool roofs. But in reality, we have spatial constraints on where these solutions are actually feasible. So on the left-hand side here, we see how we've derived rule sets to identify where current cool roofs exist and where opportunities to increase the albedo of rooftops might exist in the city, and also identified land that can easily be converted to tree cover, which includes empty tree pits that you see in the blue stars in this figure, but also natural land cover greater than 2 meters from buildings where we can actually put solutions. This is where these solutions can go, but we also want to know where they can have the highest impact, which we can sort of get information on using this metric called the Vulnerability Weighted Excess Heat Exposure Index, which is shown in the red shading here in the map of the city of Boston, where the more red areas represent densely populated regions with relatively high social vulnerability that also experience relatively high excess heat conditions during the summertime. And if we give ourselves an additional constraint of a budget, in this case about $34 million, we can actually start allocating solutions that would have the highest impact on this metric to find where we would put these solutions and what these solutions would look like. And if you look at the zoom in here for East Boston, you can actually see how we've identified individual buildings and land parcels which would have a high impact via cool roof or tree canopy expansion. And so the next phases of this project are to work with our collaborators at the World Resources Institute to first expand to about 15 areas across the United States that you can see here, and ultimately to the globe, where we can inform decision-making in data-scarce regions such as the Global South. So thank you to those who have been working on this project with me, and thank you all for your time today.